इसको लगाना ऐसे ही है। Okay, so good afternoon, all of you. And first of all, I would like to thank Professor Prabhakar and all the organizing committee who has invited me for this talk. Uh, so I'll be talking on artificial intelligence applications for safety critical systems. So because this program, this FDP is based on the artificial intelligence and machine learning. So I hope all have now understood uh, about the artificial intelligence and machine learning. Okay, so I want this session to be quite interactive. Okay, because the main thing is you need to take up something which I'm going to deliver over here. So anybody can let me know like what is the machine learning or what is the artificial intelligence? Mm-hmm. Okay. Okay. And so what is the good? So what is the difference between the machine learning and the artificial intelligence? Because generally the machine learning, somebody say machine learning, somebody say artificial intelligence, but there is a very thick line between these two. What is the difference between these two? Machine learning and artificial intelligence. Okay, I'll clear all these concepts over here. So I'll be talking on some of the applications that are based on the safety critical systems. So because this is related to the medical domain and which is the safety critical system. So here I have taken specifically the nuclear power plant, because the byproduct of the nuclear power plant is basically used for the medical treatment, for the cancer treatment, for like for example you see like Tata Memorial Hospital. So it is all about the application of the radiation, or when you see the sonography, right? So it is all because of the radiation effect. So I'll be touching on the various applications of the AI in the nuclear power plant. So first I'll be demonstrating the working mechanism of the nuclear power plant and the safety critical systems. I want to emphasize on the safety critical systems. So what are the safety critical systems? So these are the systems, the failure of which can lead to the catastrophic disaster, or it can lead to the loss of human life even. So there are the various domains where we make the use of the safety critical systems. For example, in the medical domain, in aerospace domain, in the nuclear domain, in defense domain. And in these domains, for example, you might have heard like in the medical domain, there was the accident that had taken place by using the Therac machine. So Therac was a machine which was used to treat or to inject the dose to the cancerous patient, and it was used to monitor some of the parameters, some of the important parameters of the patient, of the cancerous patient, and accordingly it gives the dose to the patient. But because there was some bug in the Therac machine, and because of which the patient got higher dose, and which led to their death. So you see like the impact of the bug in your system, right? And AI can really help a lot for all these for all these errors, for all these bugs. So these are so this was the example of the safety critical system, because the failure of which has led to the loss of human life. Okay. So okay. So first we will see uh, what is the nuclear power plant, what is the working mechanism of the nuclear power plant, and why it is important. When you work on the AI field, you have to first understand the domain. See, without domain, you cannot understand the depth, and you cannot really identify where your AI can help. And it is not only about the AI, it is about like any software. You first need to understand the domain, the roles and responsibilities of the uh, of that particular utility, and then you can identify what are the important aspects of this utility. You can segregate those aspects based on the safety category, non-safety category, and accordingly you have to design the system, right? So we will see like how the nuclear power plant works and what are the major components of the nuclear power plant, and how those components are talking to each other, because ultimately the nuclear power plant is to produce the nuclear power, right? So how those components are talking to each other to get or to obtain the required power. Then we will talk about a little bit uh, on AI. What is the concept of AI? There I will touch upon the concept of the machine learning, and then we can see what is the difference between the machine learning and AI, and we can then move on some of the important use cases which will help you out to identify the use cases with applications, to identify the applications of the AI in the various domains or in your particular domain. Okay. And then we can conclude our session with doubts, clarification of all the doubts that you may be having. So this picture, I think you might have seen in the news, in TV, international news, right? So this is a typical nuclear reactor site, basically. Okay. So what the nuclear reactor? It is the device which maintains or which sustains the nuclear reaction. And that nuclear reaction, because of that nuclear reaction, it produces the power. So first we will understand what the nuclear reaction is. Although we might have studied when we were our schooling time, like what the nuclear reaction or what is the nuclear fission. So anybody is having idea about the fission and the fusion? What is fission? Okay, so when heavy nuclei breaks into lighter nuclei, we say like it is a fission, and the fusion is a reverse phenomena. When the lighter nuclei combine, it forms a bigger nuclei or a heavy nuclei, and this process is known as fusion. So we do have the fission reactors so far, because those reactors are based on the fission reaction, and many countries together are working for the fusion reactor as well, which is being developed in the France. That we will talk later if the time will permit. So, so in the nuclear reaction, as I said, the heavy nuclei breaks into more than one nuclei. Now, in the nuclear reactor, this heavy nuclei we use as a uranium. So uranium has a heavy nuclei. We do have lot of uh, elements, chemical elements that have a heavy nuclei like uranium, thorium, plutonium, right, which can be used as a fissile material. So generally, how the mechanism works basically. Suppose you do have a very light ball, plastic ball, okay, which you can see like in the market of 10 rupees, 15 rupees, like, and you throw, you will see like it will not break. But if suppose you do have a very big solid structure like a stone, and if you throw from certain height, it will break. And in the similar fashion, the heavy nuclei also has this property. It breaks automatically. So what happens in the nuclear reactor? When you do have the uranium nucleus, it breaks automatically, and after breaking, the radioactive elements, two radioactive elements gets created, and in one reaction, 2 to 3 neutrons on an average gets created, plus 220 million electron volt of energy gets released. In this is the phenomenon of the one reaction. I repeat. So when the uranium nuclei break, the it forms or it produces the two radioactive elements plus 2 to 3 neutrons, sometimes 2 neutrons, sometimes 3 neutrons, and plus 220 million electron volt of energy. That is a one reaction. Now, this neutron which has produced from this reaction will strike to the uranium nucleus, and one neutron is having a potential to create one fission reaction. So I said in one reaction, two neutrons were coming up, two or three. So again, these three neutrons will strike to the three nuclei of the uranium, and it will produce three reaction, fission reaction. Now again one reaction three, so three into three. Then next time nine fission reactions, right? And in this way, the population of the neutrons keeps on increasing exponentially. See that earlier it was 0, then 3, then 9, right? Like this. It is then 27. So it is increasing exponentially. And I said in one reaction, it produces 220 million electron volt of energy. So you can see like the amount of the energy is also getting accumulated and is increasing exponentially, right? So that heat energy basically we have to convert into the electrical energy, and we all know that electrical energy, like we can convert one form of energy into another form of energy, but neither the energy can be created nor be destroyed. Okay. Now, so this is the typical working flow of the nuclear reactor. So I have just considered some of the important components of the nuclear reactor. So you can see here the rectangular box. Here what happens, the nuclear reaction that I was talking about, that is basically taking place. So here all the fission reaction is taking place, and this is known as this component, either you can say reactor because it is producing the reaction, or you can say the nuclear core. Okay. So this, or you can say the reactor core. So here lot of like fission reaction is taking place, and heat energy is also getting accumulated. But you know, if you design any component, it has some limitation. It can sustain a certain amount of pressure, it can sustain a certain amount of temperature. If it is designed, for example, if anything is designed to sustain 100 degree of temperature, it cannot, it will collapse if you will put it in 300 degrees of centigrade, right? So every component is designed for a certain design parameters. Okay. So now, as and when the heat energy gets accumulated, this vessel is designed to sustain certain temperature. For example, 3000 degrees centigrade something, right? And beyond that, it can melt. So now what happens? We have to remove this energy because the reaction is taking place and reaction is increasing exponentially. Then because the neutron population is increasing exponentially, right? So what happens? There is an inlet and there is an outlet. Okay. So in the inlet, we flow the cold water. So in the inlet, we flow the cold water, and this is made up of some. This is a pipe basically. This is a metallic pipe, and this pipe is internally going through this, which is not shown over here. Okay, and it will now connect to the outlet. So this is the outlet. So what happened when the cold water is flowing through this, where a lot of heat is getting generated? This heat will get exchanged to this cold water, and it will become very hot. So the outlet temperature of the water is around 300 degrees centigrade normally. So it can keep on exchanging, and then what happens? This is a steam generator, and so its shape is like, rectangular, having dome shaped structure on the top. And this water, so it basically contains logically two compartments. This is steam generator. It is filled with the light water, and when the hot water having 300 degrees centigrade, that pipe touches with this water, light water, suddenly it gets converted into the steam, because we know the boiling point of the water is 100 degrees, and after 100 degrees centigrade it suddenly gets converted into the steam. And because steam has a lighter density, it has a light weight, so it gets accumulated in the top portion of this steam generator, right? So now, so the hot water have exchanged its heat to this water, okay, and it has become cool down. And again, because I don't want to lose the inventory, because ultimately heat is a form of energy, I don't want to lose that. So again, that warm water will be again be flowing into the vessel, okay, and then again this loop will be infinite in the sense till the operational period of the reactor. Generally it remains 40 to 60 years, okay. And now what happened to the steam? Because it has a lighter density, and it keeps flowing from this is the outlet, and it is connected to the steam turbine, which basically contains a shaft. And so because of this steam, it rotates the shaft, and which is coupled with the electrical generator, and it will produce the electricity. Okay. And now what happened? Like, because steam contains energy, only the steam has two types. One is a saturated steam and one is a non-saturated steam. So generally the saturated steam is a dry steam which contains more latent heat. Okay. And where non-saturated steam is a wet steam, because it contains moisture, it will not contain more latent heat. Okay. So the enthalpy of the saturated steam will be more. And so non-saturated steam, so saturated steam will be used to drive the generator. Non-saturated steam comes into the condenser, and we know like the process of condenser, how it works. So condensation is what? When any uh, like warm thing touches to the cold surface, it condenses. Okay. So what happens, like in this pipe, the cold water gets flow, and we can take from any water body like sea or ocean or any lake. Okay, and when this, so this is containing the cold water, and when this steam touches with this, it automatically condense and it converts into the water, but that water is containing sufficient amount of heat, which also we don't want to lose that inventory, so it will again push back to this loop. Okay, and this loop, so this loop is known as the secondary loop, and this loop, the third loop, is known as a tertiary loop, which is an open loop basically. Like, okay, so wherever, so generally we try to install our nuclear power plant, or we try to construct our nuclear power plant near the natural water body like ocean, like rivers or something, and if it is not possible, then we have to create our own cooling towers. Okay, so that process is also available. So this is the typical working mechanism of the nuclear reactor. And now we can look into some of the essential requirements. For example, if I want to shut down the nuclear reactor, or if I want to control the population of the neutron, because I may have to reduce the power, the grid may not be wanting that power, because ultimately it has to be connected, that power has to be connected to the grid. And as per the requirement, the power plants work. If the grid says now only I want only this much of power, so rest of the power I have to lower down the power. So how I can control the reactor? So you can see like here there are some stripes of white color and red color. Okay, so red color stripes are basically known as the control rod, generally made up of cadmium and boron. So cadmium and boron has a property, they can eat the neutron, they can kill the neutron. Okay, so this is basically hanged with the mechanical clutch. This is a mechanical clutch which is operated by the electronic relay. Okay, so the level of the control rod can also be regulated depending on how much neutron population, depending on the how much neutron population I need to control. So for example, I need to control only little neutron, so I will not insert the control rod fully, I can only half immerse. So this metallic string will be pulling down the rod, and it went. So for example, this is a kind of rod, so maybe one is fully immersed, one is half immersed, like that, one is this much immersed. So here there is a mechanism which can basically operate. So it is an auto process basically, depending on how much power demand has come, and accordingly actual power, demand power needs to be matched with the actual power, and accordingly this algorithm works, and accordingly the level of immersion of the control rod gets regulated. Okay, and the white portion basically it is known as the moderator. So we know like what is the moderation. Okay, so what happens when this nuclear fission takes place, we get the very fast neutron which has a very high energy. These are the very high energy neutrons, and such high energy neutron will not be, or does not have potential to strike to the uranium nucleus. For example, there is only one point and I want to hit with a very high speed, the probability of missing this point will be very high. But if I will throw with a controlled speed, the probability of hitting this point will be very high, right? So in the similar fashion, because the fission reaction produces the neutrons having a very high energy, or so these are known as fast neutrons, and fast neutrons are incapable to hit the uranium nucleus, and and due to which we will not be able to get the sustain the nuclear reaction. So what happens? What needs to be done? We need to low down the energy of the neutron. So there is a moderator. So generally heavy water is used as a moderator which can lower down the energy of the neutron. Okay, so it is known as the thermalization of the neutron, and that thermalized neutron can basically are capable to hit to the uranium nuclei, and which can produce the nuclear reaction. Okay, so this is the entire process, and these are the various pumps. There are thousands of pumps are there, but here I have shown typically 2 3 pumps pumping the water from here to here, pumping the water from here to here, then pumping the water from here to here. So there are several mechanical pumps, several mechanical valves, right, uh, to open or close depending on our process requirement. So this was the typical working. Now let us, so one vertical we have seen. Now we are touching on the second vertical, and then we will try to bridge or converge both the verticals on a single point. Okay. So now the artificial intelligence or the machine learning. So just to give you a real visualization, so first I will talk about the machine learning, what actually the machine learning is. Suppose there is a newborn baby, for example, okay, and like newborn babies are very curious to know new things, to touch new things, irrespective of he doesn't know whether that thing is hazardous or no, right? But they are very curious to touch. Suppose, for example, mom is holding the newborn baby and she is taking a cup of tea, for example. Now again, the baby is so curious and he will try to hit the cup, and many of the times you have seen like they got burnt. Okay, so the next time, or 2 3 times, couple of 2 3 times, he will come to know like, okay, he will try to make a model in his mind, or he will train his mind gets trained that that was the cup, that was the usual cup which mom used to take, and in that it, it remains some hot or something that has hurt me, and this was the style that mom was taking. Okay, so that all these scenarios keeps on capturing into his mind, so his mind keeps on getting trained, right? So this is the kind of training. Now this is the intelligence, this is the capability or the intelligence of the different baby. For some babies it may require only one time to understand, for some babies it may require 10 times. So it all depends on that. But they train, the crux is they train their mind like this was the scenario, this was the pattern, and that was the hitting pattern, and I need to really be very cautious for that. Okay, now Next time it may happen. So suppose this is the teacup. Okay. Now next time, it suppose she is taking the cold water in this vessel, in a glass. Now again, so if the baby will think like, okay, this can also hurt him, but what happened, his prediction may be wrong. Why? Because now it is not the tea, it is the cold water. So the example of the hot tea is a training, and that is known as a machine learning. So his mind got trained, his mind got learned, but now he have to bring the intelligence. Okay, so what will happen? So suppose the next time, if he touches this, and he see what is the observation. So this is the observation 1, this is the observation 2, and he sees, okay, so it means this kind of thing is not hurting at all. So what is happening? After giving the input, he is observing the output, and from the output, his model is getting trained or tuned. Or it may be possible, many scenarios can be possible. At one time, out of 10 time, at one time she is taking hot water, then he can accordingly adjust, like out of 10 times only one was that. So he will try thinking in terms of probability. What is, whether it is less probable like that it is hot, or high probable that it is hot. So in the machine learning, there is only one way. We give the input and we observe the output, and accordingly our mind gets trained. But so this is a machine learning. But in the artificial intelligence, what happens? We give the input, we observe the output, and that feedback keep on giving as an input. Because many of the times the outputs may change, so you have to adjust the weights inside that. Whatever your mind have already trained, you may have to adjust the weights of that what is the chance, what is the probability, what is the higher probability of particular scenario, what is the lower probability of particular scenario. So artificial intelligence is nothing but it is equal to machine learning plus feedback, because it keeps on learning from the feedback. It is not like one time I have trained and next time I am not applying the intelligence. For example, a very second example, suppose uh, some I do have some person to want to introduce, and I want to create a negative impression against him. So what I will do, I will keep on telling you the negative things about him for 1 month, for 2 months. So you people will have a negative impression about him. So when you will introduce that one, you will always have a fear or have a cautious against them, keeping in the mind, because your mind is trained basically, right? But after confronting, like for example, uh, 2 3 months after confronting all the scenarios, you will try to adjust your mind, that whether it is right, or for some person it may be wrong also, right? So because you are getting the feedback of that person, so here your mind works. So basically, where artificial intelligence is the replacement of your mind. After observation, it gives the input to the model, to your model is what, your mind, and accordingly your mind gets tuned, and the tuning is nothing but it's the adjustment of the weight, okay, of the different parameters that have set in my mind. Got it? So uh, so this is a difference between two. Now let us see like what is the life cycle of machine learning. So first we should understand the machine learning is a data driven technology. It always works on the data. Okay, if I'm not having the data, okay, so it always works on the data, right? But the data must be a meaningful data. So for example, in a system, I do have lot of data. For example, see, if there are different kind of tests, okay, for example, the test of malaria, the test of typhoid, right? So different parameters are being monitored, different kind of data. The body is same, but they are monitoring different parameters, right? So first we need to understand when we design, when we want to automate the things using AI, we need to understand the context and the relevant data needs to be considered. Otherwise, what happens? The output is sure in the machine learning, but whether it is correct or not, it totally depends on the healthiness of your data. Okay, so data in the learning life cycle, the data handling plays a very important role. So first thing is we have to get the data depending on the context, in which context I want to uh, make the system. Then we have to prepare that data. In the data preparation, I may have to clean that data. For example, there may be some raw data, there may be some uh, maybe outliers also, right? Eh? Yes, or maybe some are junk data also that may also have to remove. So those we have to remove. So it is a data preparation. Then data wrangling means you have to only identify the meaningful data, because many of the data are important but not important with respect to the context for which you are going to automate the system, or you want to design an AI system, right? So it is the context insensitive categorization, right? Yeah. So you have to do that, and then you have to really analyze the data. Yes, this is the perfect data that I want, and by which I can train my model, and accordingly, whatever I want, the output, that is sufficient data to give the output. And from that data, then we have to train the model, right? And after training the model, we need to test it. So this is but obvious, when we develop any model, we have to test the model. So generally, if I do have 100% of data, 70% of the data is used to develop the model or train the model, and 30% of that data is used to test the model. Okay, so for example, what does it mean actually? So if I do have a data like that, and from 70% I have trained, okay, this was the input, this was the output, this was the input, this was the output. So from there, from those in set of inputs and outputs, only for 70% data, only with 70% of the data, I have trained the model. Now, how I can test? These are random data, right? So I can test with the rest of the 30%. If I am giving this input, because of this trained model, I can predict, okay, this should be the output, and I can really verify this output with the actual output, whether it is not. So I'm just ensuring whether my model has trained perfectly or no, right? So all these inputs will give some output, and I will match those predicted outputs which were the outcome of my trained model with the actual output that was supposed to. So this will be the testing of the model. And then once I'm satisfied with my testing process, I can deploy that model. Okay. Okay. So the machine learning is basically, you can say, it is a subset of artificial intelligence, because AI is equal to ML plus feedback. And how we can denote the machine learning? So basically, it contains the layers, minimum three layers. So one is the input layer, one is the middle layer, one is the output layer. And the input layer is where we give the input. The middle layer is our artificial intelligence model, which basically gets trained, and the output layer we get the observation, okay, or the prediction. Now, when it requires more than hidden layer, so, or when your data is very complex, complex in the sense, for example, not only in the terms of voluminous. See, if data complexity can is not directly proportional to how much volume of the data that you do have. It is complex how much category of the data that you do have. Categorization. So maybe if you are having very small set of data, but if the categorization of those data is very long, right? So you have to analyze the categorize or those categories, and probably then I may have to use more than one hidden layer, because one hidden layer will be used to categorize the data of one type or two types. The second hidden layer may be used for rest of the one or two types. In this way, I can have three layer, four layer, depending on the complexity that we do have. Okay, but if I do have more than one hidden layer, that is known as deep learning. So here the concept of deep learning comes in, where we need to have more than one hidden layer. Because of the complexity of the data, I want to address the complexity of the data, the diversified complexity of the data. For that, I need more processing power. See, one layer means I require more processing power, okay, to filter out. So it is known as deep learning. I want to understand the uh, lower or the more detailed level of the features, not only the broad level of the features, more and more detailed level of features and diversified features. Okay, so this is the hidden layer. Clear? And this is known as neuron. So our mind basically contains lot of neurons, uh, thousands and millions of neurons, and daily several neurons take birth and several neurons die. And that is the reason, the memory will also deteriorate, because each neuron contains some memory and processing power. Fine. In the similar fashion, each neuron is containing some memory and the processing power. And I said daily lakhs of neurons, thousand of neurons is taking place, and thousands of neurons are dying. So, so the dying means whatever the memory it was containing, that is going off, but not completely going off. Why? Because it is connected to the other networks as well, right? So the part of that one will keep on vanishing, or till that the effect will keep on vanishing, because it is a network of those neurons. Every neuron is connected with every neuron, right? So all the memories are basically shared with each other. Okay, so there is a concept of the convolutional neural network, and that is very important for the image processing basically, because generally images are very uh, large in size, very voluminous. Why? Because like every image is a matrix and which contains rows and columns, and each element represents the pixels and its intensity, right? And each intensity, if you are working on a binary image, okay, it may contain only 0 and 1, but if you are taking a gray image, it will take 0 to 255, and more colorful images, then it will take more intensity, right? So if you are playing with the colored image, it is more voluminous, the data is more voluminous, and hence the normal machine learning algorithms or mechanisms will not work, will not be able to process such a huge amount of the data. For that, the convolutional neural network plays an important role, which contains certain layers, and how it basically works. So first of all, there's an input. So you just scan the image as an input, then it will go into the convolutional layer. What convolutional layer will do? It will extract the all the features of your image. Okay, so it is just trying to process your the features, and it is extracting all those features. Okay, and it will try to create a feature map. Okay, for this image, these are the features. For this image, these are the features. So this layer contains the feature map. Okay, then there will be the pooling layer, and pooling layer basically is used to reduce the dimensionality of the data further. If you do have a lot of features and you are only concentrated or you are only interested for certain features, the rest of the features can be discarded. Okay, so we can reduce the dimensionality of the data using the pooling layer, and then with the convolutional, you can have the ReLU layer as well. And what actually ReLU layer does, it is also known as rectified linear unit. So basically, it is used to it is an activation function, and it is used to introduce the complexity into the images by introducing non-linearity. Why? Because generally images are non-linear in nature. Okay, so non-linear, like if you can see like any image, for example this. So here some color, like here some color. So it is generally non-linear in nature, and that non-linearity can be introduced by the ReLU layer. Okay, then softmax layer is the output layer, and it can assign the probabilities. Okay, the probability of that particular is, for example, you are trying to analyze the image, which can reflect the cat, the rat, or the pigeon, or the uh, uh, parrot, and it can assign the probability that if this for this image, the probability of the parrot is this, the probability of the pigeon is this, like that, and some of those probabilities must be equal to 1. Okay. Hmm. So, and we can have this convolutional plus ReLU plus pooling, more set of layers. This is a one set of layer, because for every image I need to have a convolutional, I need to have a ReLU, and I need to have a pooling. And these, depending on the your data diversity, depending on the complexity of the data, complexity of the images, we can have more than one set of layers. These three layers. Okay, so I have just shown as an example of two layers. Okay, so now let us consider some of the applications of the artificial intelligence. So one is a new digital twin. So how many of you have heard about the digital twin? Sorry. So how many of you have heard about the digital twin towers? No, no, it is no, not exactly. Mirror image, right? Okay, so it is a kind of twin, basically, right? So you are creating a twin. So you might have heard, like, many countries, developed countries, are trying to create a twin of the country. Is the Singapore is now working on to create the entire twin of the country. So twin means, like, the twins take birth, right? So both have the similar features and look and feel everything. So digital twin means, here I want to recreate the physical entity into a digital form, so that I can know more and more insight about that physical entity. For example, if a digital twin of myself can be created without analyzing myself, just after analyzing the digital twin, every insight can be known, depending on what all the things that I have modeled in the digital twin. So you have to choose what all the features, the relevant features you need to model in the digital twin, and how it works. Basically, I discuss right now. So this is a very important concept of digital twin, creating a digital twin and of nuclear power plants, because lot of, like, nuclear power plant is a very safety critical in nature, and any deviation can lead to be very catastrophic disasters. For example, you have seen um, the scenario of Nagasaki and Hiroshima and Nagasaki, right? The bomb was thrown long back, and still the impact is persistent. Okay, and why? The reason is because the radioactive element has a half life that ranges from few milliseconds to million of years. Okay, so its impact is going to be for a longer period of time. Hmm? So you might have seen several other accidents like Fukushima in 2011, Chernobyl in Russia in 1940, then in Three Mile Island in USA. These are the important nuclear reactors accidents that have taken place. And so it is very important to analyze each and every process that is going or that is taking place inside the nuclear reactor at a very minute level, and which may not be possible in the real entity, because of, many of the zones are radioactive zone, where the entry to the human beings are not allowed, or uh, we cannot also, uh, monitor those areas, right? And hence the digital twin concept came into the picture. Many of the countries have made the digital twin, and we will see the advantage. But how we do that, first of all? So what happens? Let us try to understand in the nuclear reactors what are the important things that happen. So there are various, mechanical components which are working, and some of the components I have basically discussed how it basically works. But that was in a very abstract level. It is a very complex, and if you go further into the details, but it contains, in crux, it contains thousands of valves, thousands of pumps, thousands of pipes, metallic pipes, thousands of heat exchangers, thousands of, motor pumps, different kind of motor pumps, thousands of tanks for the processes, and we need to monitor the healthiness of these components, because if the malfunction of any component may deviate your process, and which may be hazardous, right? So there are the various sensors are there, which basically gives the healthiness of your particular physical entity. For example, your valve is closed or open. So there will be the sensor which is known as limit switch. So in the limit switch position, it will automatically find it is a open or it is a close, because many of the times the valve needs to be closed. It may be requirement of my process and which is not actually, right? Or pressure of that particular you know tank, right? Or the temperature of the fluid, or the flow rate of the fluid that is flowing into the pipe. These are the different parameters. So we do have lot of sensors: flow sensors, pressure sensors, temperature sensors. Those are RTD sensors. Okay. And those sensors are also very interconnected, because it may require like getting input from another sensor and throwing out to the other sensor, based on which some processing needs to be done. So some sensors are smart sensors as well. Okay. And so you have to model all those sensors. Okay, you have to identify what all the important sensors, what are the capacity or the scope of the work will be decided by you, actually what you want to do. So you have to model this. Then there will be a lot of computer systems, network systems. You might have seen the control room, for example, like in the mission Mangal. You might have seen there the control room. The control room remains, which is generally the nervous system from which you can operate, okay, everything. So here in the nuclear reactors, the control room remains, where you can control the nuclear reactors. You can increase the power, decrease the power. You can monitor the different, the status of the different equipment, and you can give the command to the uh, field instruments, for example, closing the valve, opening the valve, and so on, right? So all these things are basically done are in the control room. You do have a lot of alarm windows, where if any process is deviating, the alarm window will blink, and so that operator attention goes to the alarm windows. So these things are, you need to model basically those things. So this is the computing and the networking systems you need to model. You every system, how it is interacting with the other system, that has a network protocol. Some may be working on the UDP protocol, some may be working on the TCP/IP protocol. All those protocols basically you have to model, right? Analyzing those. Then the physical phenomenon, when should the uh, for example, it should be closed, when the valve should be closed, when it should be open, depending on the process requirements, for example, or the pump should be on or off, or heat exchanger should be on off. All those things needs to be modeled. Physical phenomena needs to be modeled, how the real entity is changing its state. Okay. Your physical assets means where the physical entities are basically placed, that also model. Why you need to model those things? Because maybe there is a fire prone area, and you are putting some flammable object over there, which is not permissible at all. I mean, this is a very small example. So you have to monitor some of the physical assets. Then you have to monitor the procedures and the human actions. This is important aspect, because why? Human actions in the sense, when you are in the control room, there are the operators. Operators work in a shift, 8 hour shift. Three shifts remain 24 hours. And if he sees any alarming condition, operator needs to take some action. Many of the actions are automatic, but then also operator needs to monitor whether those actions have been taken automatically, or otherwise many of the action needs to be taken from the operators also. So those things also needs to be monitored, whether the operator is taking the right actions or no, because ultimately if the operators are not taking the right actions, it could be hazardous, right? So those procedures and the human actions also needs to be modeled. Now these are the typical things basically that I need to automate. So first, the first thing is I have to identify what are the important aspects that I need to model in my digital twin, which I need to track, or I can keep monitoring in the digital twin to know more and more insights about those aspects. Okay. And now, so after modeling this, you have, so these are, this is the identification. And now in the digital twin, how you will make the digital twin. So as I said, it is a data-driven technology like AI, because everything like this has to be modeled using AI. You have to understand the data pattern, and accordingly you have to send the recommendation also what needs to be done if some there is deviation in the process parameter. So basically in the digital twin, the data and information management plays a very important role, because you can see a lot of voluminous data needs to be stored somewhere. There should be a proper mechanism how those data can be categorized, can be wrangled, can be stored somewhere, so that the proper access of those data by the respective systems can be taken. Okay. So that includes your storage, your sharing and accessibility. Maybe some of the data is should not be accessed by some particular device. Those all the things you have to model. You have to give the access rights, uh, user interface and visualization. Uh, if I should be, for some data, for some field equipment, I may be given the control, but for some field equipment, I may not be given the control, neither I may not be permit to see. So all those things you have to model. Okay. Then there is a modeling and simulation that is important now. So you have to model, you have to analyze the data analytics. You have to create the physical based models. Physical based models means, see, for example, you might have gone through the physics like PV is equal to RT. This is a kind of model. So like how that what will be the temperature and pressure relationship. When the temperature will increase like this, the pressure will increase like this, and accordingly we have to take some action. So all those physical based models needs to be created, and artificial and machine learning models needs to be created. The data models needs to be created, and all the other models that are important, we need to create those models. So after making the digital twin, but the story doesn't end here. The main important crux of the digital twin is it should reflect the current scenario, what is actually in the real entity. So if you are making as a passive component, it doesn't work. It needs to be dynamic. So it has to be connected by the from the real entity, so that all the respective data can keep flowing here, and accordingly the state of the twin keeps on getting changed. Okay. It should reflect the current dynamics of the system. Clear? And so all the asset information, real time sensor data, plant operation maintenance, all these data will keep on flowing. And then if those data will be analyzed by using machine learning models, AI models, and if anything gets wrong or what action needs to be taken, all those actions and recommendations can be given up to the real operator who is sitting over there, or to the real, machine, or the real computer based system who is uh, inside the real actual reactor. Okay. So, that includes what all the actions and recommendations, diagnostics and prognostics. For example, any particular electronics card is going to fail, or its lifetime, its remaining lifetime, useful lifetime is only uh, you know 2 months. You need to repair it, like those. Or anything has malfunctioned, which is not here it is not possible to track. There could be some malfunctions. What should operation and maintenance people should do? Or autonomous operation and control to send a command to the device to take the respective action. So I hope the concept of the digital twin is clear. What is actually digital twin and why it is used. So one beautiful use case of the digital twin developed by the France is see, this is a secondary side. You can see like this a steam generator, and it is going. This is basically the turbine. Okay, so inside this, although there I have shown only one line, but you can see there are a lot of mechanical components are basically in between these, right? So what was happening in the France? There was a nuclear reactor, and it was supposed to give from the digital twin. The digital twin was showing that this reactor should give 963.5 megawatt of energy, but actually it was giving 959.9 megawatt of energy. So there was a loss of almost 4 megawatt, 4 to 5 megawatt, and which was a very critical loss because 1 megawatt cost is very much. Okay, and hence the the digital twin basically helped to find out the root cause of that, and the root cause was there was some leakage, some internal leakages in the reheaters, and those internal leakages were not able to get revealed by the traditional methods. And in this way, they could save lot of economy, and they could, you know, correct the process. They could rectify the fault, and they could, you know, save lot of revenue. So this was the real use case of that. Okay. So there is a one use case known as Cortex, and it is a European project, and this project is of 55 lakh billion euro. Uh, the cost of this project is so, and it is from the participation of 11 countries. Okay, and it started in 2017 and end up into 2021. So almost it was a 4 to 5 years of project. Okay, and in that project they could use they could develop an AI system which can understand the internal dynamic of the core of the nuclear reactor core, what is happening, how many neutrons are getting created, how what is the rate of getting controlled, right? So all those things can be monitored because ultimately the neutron is the ultimate source of accident or of the radioactivity, right? So they could develop a AI based system which can basically keep track the internal process at a very detailed level, which is not possible from the normal traditional mechanism. Okay. Okay. Now, fault detection or yes, so it is well in many of the times you are not able to understand where the things are faulty. For example, there are thousands and lakhs of sensors are there in the field, and many of the times I'm not able to detect that this sensor is faulty. Why? The reason is I'm just giving one small reason. Suppose there are the triplicated sensors. So first let us understand what we mean by triplicated sensor. So suppose I want to monitor the temperature of a particular water or a particular fluid. Okay, let us say water. Okay. Now there are the temperature sensor, and this water temperature plays a very important role because based on the temperature of the water, it is doing safety related activity. Let us assume. So I do have one sensor, for example, sensor one, and which is giving the temperature T1. Okay, and here in the operator there is a system, computer based system, who is getting this temperature T1 here. Operator is sitting and it is also monitoring. Okay, fine. Now suppose it is giving T1. Now how I can find out whether this T1 is right or no? I don't know. See, if somebody is saying something, how I can verify he is saying correct or no? So what happened? Generally, what? So you can apply two sensors, and suppose it is saying T2, and here it is saying T2. Now one is saying T1, one is saying T2. Then to whom I rely? Then also I don't know who is saying right or who is saying wrong. One may be right, but I'm not able to identify who is right and who is wrong. Right? So what I can do, I can introduce one more sensor S3, and suppose it is giving T2. Then I can see, okay, the maximum voting logic I can apply, and I can see the 2 out of 3. The 2 is giving T2, so this is the actual value, and I can ignore other one, right? Okay. So this is known as the triplicated logic. So generally we use the triplicated logic. क्या है कोई डाउट? तो ब्रेक ले लेंगे क्योंकि अभी एक टाइम तो लगेगा अभी. हाँ ठीक है तो वी कैन ब्रेक, नो इश्यूज, वी कैन टेक अ ब्रेक. हाँ ठीक है. ये रख दो. So one of the use case you are seeing the fault detection of the sensors. So as I said, there are a lot of sensors in the field, and many of the sensors are basically they are not used uh, for or some of the sensors are redundant in nature, and hence we are not obtaining the data from them because these are the sensors which are to be used when the main sensor fails, and then it can take over to the sensor. So, so what happened like, but in the AI-based system, what we can do, we can retrieve the data from the sensor, okay, and this data. So generally, we can try to analyze the normal data behavior, the normal data pattern. So normal data pattern of the sensor, for example, is this, and we are getting the deviated data from the normal data, and so this is to be classified as a fault data. So in this way, we can identify like which sensor is getting faulty based on the data pattern that we are taking. Okay. So AI is also used in the predictive. So generally, what happens? The predictive maintenance is a maintenance like, for example, if something is going to fail, if I am aware of, or if somehow I can come to know that something is going to fail, I can take the preventive action rather than the corrective action. So there are the two kind of actions. One is the preventive action and one is the corrective action. So in the preventive action, we basically take the action before actually that event takes place so that we can avoid that event. Okay? But in the corrective action, but once the event has taken place, we have to repair. That is the corrective action. But many of the times, the corrective actions are very costly. For example, here there is a turbo generator. There is a one company, Rosatom, in the Russia, because Russians are very good in the nuclear research. They do a lot of nuclear reactors. So Rosatom is the name of the company which is responsible for design, construction, operation, and maintenance of the nuclear reactors across the Russia. And he has made AI-based system which can do the predictive analysis of turbo generator, that is a turbine. And turbine is the costliest component in the nuclear reactor. And in case there is some problem in the turbine, we have to shut down the nuclear reactor So this is known as a emergency shutdown. Emergency shutdown means I there are the two kind of shutdown in the nuclear reactor. One is the plant shutdown, and one is the emergency shutdown. So plant shutdown is basically taken place annually or biannually just to repair all the components or check the or monitor the healthiness of all the components. But emergency shutdown basically are not the routine shutdown because some accident or some event has not been postulated and that event has occurred. So to maintain the reactor in the safe state, we have to do the emergency shutdown, but those are very costly. So if one day our nuclear power plant remains in shutdown state, that will be the loss of 1 million euros per day. So that is the loss that the nuclear power plant utility needs to bear. And in case of emergency shutdown, it can remain shut down for at least 2 to 3 years. Oh, sorry, 2 to 3 days. Okay, so 2 to 3 days means for per shutdown 3 million euro loss has to be there. Okay, and there are for example there are 61 reactors across the country. So on an average, if you say if there is an in 1 year 5 reactors are shutting down, 5 into 3 like 15 days, my plant has been shut down. So 15 million euro has there will be a loss. So a very good use case, artificial intelligence use case, has been made for the predictive maintenance of the consumer data, which can basically analyze the health, keep on monitoring the health of the consumer data, and it understands the data pattern, the normal data behavior when it is in a healthy state, and once that normal data behavior, the trend of the normal data is changed, you can come to know like now there is a emergency state or it is going to malfunction and accordingly the preventive action can be taken place. The isolated the defect, identified defect is isolated and taken for the repair and we don't need to shut down the nuclear. So this is one very useful use case. Now the next one is static flow accelerated corrosion wear rate. Now, as I said, there are a lot of mechanical components, and in the mechanical components, a lot of fluid keeps on flowing up. Although we maintain the pH value of those fluids to ensure that the metal should not corrode, but it still it gets corroded because of the pH value. It is hard to maintain the absolute pH value, and even if you are able to maintain the absolute pH value, then also like so many other factors are included. You can increase the life, but these are corrosive. But the corrosion process is a very standard process, and we know like the trend of the corrosion process. So we know like once it reaches to one level, then the situation of the then the danger situation occurs, and then we have to really take the action, and that will be the corrective action. So what it does, this AI application, from starting from the origination, because generally it keeps recording the normal trend behavior of the metal, like the sound that is coming up, the flow of the when water is flowing or fluid is flowing inside the metal wall, what is the sound that is coming out in the corrosion, the sound will be changed. And so many things, so many other properties like keeps on monitoring. And when we see like there is a trend, there is a deviation in those parameters, it can come to know like now the corrosion has been started and the preventive action can be taken place and the Results were very beneficial. It has been implemented, and almost for this 20,000 inspection data set has been analyzed from different units, and the images were captured through the drone. The drones images have been processed through using the convolutional neural network and applying the AI model to understand the normal behavior and to identify the trend, the deviation of the normal trend, and accordingly it can predict like now, yeah, the corrosion has been started and the remaining useful life will be like this, and accordingly we have to take the preventive action. So it can also help in mm, reducing the manpower because generally what happens, there is an inspection, there is a quality assurance group which basically performs all the inspection checks, routine inspection checks of every component. Depending on the life of the component and the degradation trend of the component, the routine of the inspection of that particular component is used. Okay, based on the international and national practices, and we can reduce this inspection checks also by automation and so we can also identify the damage in the concrete structure. So if you remember the first figure that I was showing, that a nuclear reactor and the steam generator that was enveloped into one dome shaped structure, and that dome shaped structure is known as the containment wall. Okay, so generally it is 1 meter thick wall, and the entire radioactivity is contained in that containment. So the first safety breach is the reactor core itself where the reaction is taking place. In case there is some release in the radioactivity that can be contained in the containment, which is maintains the negative pressure. Negative pressure means like everything moves from the high pressure to the lower pressure. So if I maintain this building, this room in the negative pressure, the outside elements can come inside, but no inside elements can go outside. And in this way, I can uh, ensure that no radioactivity can be released from this area. Okay. So those technology, basically these are the civil technologies that are being used, but we can easily identify the damage in the structure. So like the metallic corrosion has some pattern, uh, in what manner basically the corrosion will be propagating. In the same way, here also the damage in the concrete structure also has a systematic approach how it keeps on degrading, and that will analyze based on the pictures that are taken. So here the images are basically used in process by the AI algorithm, and those again will compare with the images will be compared with the normal images, and it will expect all those features. So the features will be compared, and any trend, any substantial trend in the features will indicate that there is a like damage in the structure in the civil structure has started. So it can also analyze. So as I said, here we have to use the deep learning because so many other features are also I'm trying to analyze, like the corrosion, because inside the containment there are the key structures as well which are giving support to all this conflict. Okay, so to identify the corrosion, the cracking, the spalling, all those features can be identified using the deep learning. So it detects, it shows the high detection rate for all the kinds of damages. And so it is As I said, it is used to estimate what is the remaining useful life of the component, and this is known as a prognostic. Okay? So it can help in various aspects. It can help in the inventory. For example, we will have to maintain the inventory of all the components because if anything fails, I should be able to have a, I should be able to repair that with a new part, right? So there is a spare management system, and many of the time what it happens like many of the components are very costly, and if we purchase, many of the time the prediction that is that after 2 months or 3 months or 6 months, one component will malfunction. But many times it happens like even after 2 years, that component remains healthy. And in that case, what happens? The component that we have procured and keep in our inventory, its life keeps on deteriorating, right? Because the reliability engineering curve, it follows the bathtub curve. So everything has its aging, so it started aging. Years, and when you are not using, then the aging starts very rapidly. Okay, so those are the very costlier components. So the AI system can help us a lot to save the economy for spare management also. So that in we can judiciously we can identify uh, the components which are going to fail in the future, and accordingly I can start my procurement process. Anyway, so this is the spare part management. Okay. So then the human error detection in so human error detection, as I said, in the control room, there are the various operators, and against any event, there is an event management system. There are some instructions that needs to be followed by the human operator to adjust those events or to keep your into their power plant in the case. Okay. So what you do, for example, in what here is being done, you can keep capturing the images of the entire control room and the operator. Like a very for a very good visualization, you must be knowing that now there is a smart car which can even alert the operator whether he is in drowsy state or he is in sleeping state or like any drinking state or whatever. Why? By analyzing it with biometrics, like or eye vision, actions what he is taking, and he can give the alert of it, right? So that is also based on the AI. Why? Because normally in the normal situation, it analyzes the behavior of the operator, and in that particular situation where the operator is feeling drowsiness, he will analyze all those behaviors and he will find a substantial difference between the data pattern of the LLC was in normal state and when he was in the drowsiness, right? And the similar thing basically is being done here. The images are captured, operator images are captured, and again any event, the events are getting simulated. So there is a simulation basically. The events are getting intentionally simulated, and we have to monitor what actually the action has been taken by the operator, and that is being captured in the form of image. And after analyzing those images, you can easily find like the operator alertness with respect to its functionality, with respect to its job. Okay. So basically, we have to just correlate all these process variables, which are the features of the operators, maybe blinking of eyes, the frequency of the blinking of eyes, the frequency of the speed of the car, or like the action, the other human actions. It can also be used by for like other purposes. For example, the emergency door closing system, uh, for the loss of coolant access. So as I said, lot of heat is getting accumulated in the reactor, and we may have to remove that heat. But if suppose if in the steam generator the water is very low, and it is not able to remove that heat, because ultimately the water is not removing that heat, right? Because the heat gets exchanged into the water, and if the water is very less, it will become very high temperature, and no water will be remaining to exchange that. So all those things can be monitored here, like how the vertical degradation, trend of the water in the steam generator. It can also identify if there are some leakage. So all those use cases have also been designed and developed and deployed also. So, so this is the for event identification also. For example, if any event has not occurred and it is going to occur, so that those kind of scenarios also can be captured by AI system. We can design our AI system to capture those events. Okay, so in conclusion, we can see like there is enormous benefit of the AI in the various use cases. We have considered the domain, the nuclear power plant, because AI is a domain dependent. So I intentionally consider one domain so that you can easily understand the importance of the AI, in what context you are going to apply, and accordingly, judiciously, you can use your AI applications in your particular kind of domain. And we have seen like it can be used for design optimization, for by how the design optimization. For example, if you have seen there was a problem in the leakage in the secondary side, there was a France company microscope who identified because of the leakage there was a loss of the power, and so they have optimized the design also. It can be used for the various design optimization, for construction safety surveillance, for safety. For example, uh, if any person is working on the construction site, he is wearing helmet or not, right? So all those trends can also be monitored. Operational support, it can operational support needs to identify the healthiness of the operators and all, and decommissioning optimization. So if I want to decommission the nuclear power plant, it is a process. So all those activities can also be monitored. So ultimately, in the design optimization and prediction for virtual sensing can also be done by digital tools. uh, Anomaly or transient detection for equipment health monitoring, plant diagnostic and prognostic, enhanced operator action, cyber attack detection, physical protection, okay, operator decision support, smart site, digital twins, and these are the various, you know, applications here where we can make the use of AI. So this is a session only to discuss some of the applications so that you can easily understand the importance of the AI and ML with respect to your field. And for more, basic mathematical knowledge, because AI is totally based on your mathematics, so mathematical models you need to make. So I I do have one my YouTube channel as well, EGML. You can go to the EGML and you can listen all those videos to know more about like any particular algorithm or how the algorithm works or how the mathematical what are the mathematical fundamentals and all. So all those things can be okay. So in case of now any doubt, these are the references where the presentation has been taken up. All the so you can refer uh, for the more details. Okay. So in case of now any doubt about the AI, about the ML, or about the basic concept, or about the normal concept, I'll be happy to answer. And Madan, Professor Bhavesh, only question to you, important of the topic. Wish to extend my heartfelt thanks to Dr. Lalit for sharing his valuable information regarding AI in the domain of nuclear energy, nuclear power plant, and its usage in the particular domain of the nuclear power plant. Further, I would like to ask all the participants if they have any doubts, they can ask the doubts to the lecturer. If you have doubt, have to ask to the time. I think this will be definitely helpful to all the participants in the future as well. If you can remain in contact with me, we may share his credentials. Any questions? How do we make that data for the crack detection of the structure? Crack detection basically you have a drone. So drones because this is generally is a very radioactive drone. So you have the micro drone which keeps on going. It can operate from the control room. It keeps on going. It can capturing that data and that data directly goes to your AI based systems and which basically process all those data which is condition. So this is our routine. So you require some reference data to compare and to analyze that whether okay that fact whether creative of the structure are severe or it may be severe in the future. So basically there are the three types of learning. One is the supervised learning, and one is the unsupervised learning, and one is the reward-based learning. Okay. So this was the problem of the unsupervised learning. I tell you the three difference. What is the difference among them? So in the supervised learning, what happens? I do the labeling of the data. See, if I get this data, X1, it is bad. If I get X2, it is good. If I X3, it is bad. Or if I X, or if I from X1 to this, it is good. Like that. So I already know what is the meaning of the wrong and what is the meaning of the right. So that is known as the labeled data. I am doing the labeling. I am performing the labeling of that data. Okay. Now suppose there is a black box. You don't know what is right and what is wrong. Okay. So what happens? Like normally uh, when you bring something or when you start something, your for example nuclear reactors or you have a country and you keep capturing the data and those structures are so strong like up to 20, 30 years, nothing like happens. Okay. So you keep on monitoring that data. Like for example, you have monitored the data for 10 years, for example. Okay. And after that, and you have captured the data, captured the trend of the data, and you have analyzed that data. And after 10 years, you are finding now you are some differences in the data, and you are and continuously with the time, those differences are towards the failure trend, towards that trend only. Right? So, for example, previously it was low one process per value, now it is more low. It means that degradation is happening. Here you don't need to label what is wrong and what is right. You are already having the healthier data unlabeled. This is known as unsupervised learning. There is no definition is not required at all. But based on your starting, you know like everything is right and this is a normal trend. And like so this it automatically makes the definition. It automatically creates the definition what is wrong. Okay. So in this way basically it is being done. And now in the third one is the reward based. In the reward based, what happens? For example, if a student appears in an exam and he fails, then he will not get a reward, right? So see, he will automatically take the decision to change his study habit, right? Because it is not he did not get reward. But suppose it gets passed, or after changing habit it gets passed, then it will continue to that, or it will try to enhance to that. Right? So it is a reward based learning. It is also a learning. So those kind of learning is also there machine based. Okay, so that will so it is all depends on the context basically. Context based. What kind of data that you have, what kind of analysis that you want to perform with the help of your data. Any other query? Participants? Okay, thank you. As a part of the organization of this activity, I extend my heartfelt thanks to Dr. Singh, who came over from Mumbai. And moreover, he gone through the overnight journey. He became late due to the divergence of the train. He almost reached 6 hours late in Nagpur. He is supposed to leave in the morning. He reached around 1 p.m. in the afternoon. Despite that, he took his valuable time. He spared his valuable time and shared his knowledge. And I hope whatever the knowledge, whatever the insight that he has given as far as uh, power plants are concerned, nuclear power plants are concerned, I hope this knowledge is definitely going to help all the individuals sitting over here in their perspective, their domain, and definitely it will be helpful to their student as well. So again, I thank Dr. Rohit Singh from my bottom of the heart, and I hope the same kind of cooperation as well from him. Uh, Thank you, sir. Once again. कसं पीपीटी घेतलं ना पीपीटी घेतली आहे ना त्यांनी केली तुम्हाला कॉपी ग्रुप वन ये ठीक है इधर मैंने 9 ग्रुप बनाया किसी में 6 है किसी में 5 लोग Announcement to all the participants. Actually, it's nice. We are having one taken up journal article discussion.